my name is Sean Arya, and this is my submission for Exam Mini Video 5, Prompt 1. Here on the first page, I have the wild-type DNA sequence copied at the top. The sequence is transcribed as seen here in the second section of the page. I've transcribed both the top and the bottom coding strands in order to identify which strand meets the requirements as outlined in the prompt. The mRNA sequences for both strands are in red. The strands above the coding strands are shown for clarification purposes only, as I will orient the strands from now on in the 5' to 3' direction. Under the resulting mRNA strand section are the two mRNA strands that resulted from transcription in the new orientation. I still needed to identify which strand to use in order to continue, so I translated the mRNA sequences to find out which amino acids they coded for. As you can see, the bottom strand, mRNA2, contains the 5 amino acid protein requirement outlined in the prompt. This is the one I will use. You can revisit the protein amino acid sequence to compare the protein amino acid sequences we will talk about further in the video. Second page has a lot of information on it, so we'll take it piece at a time. The key at the top of the page can help you follow along during my explanation. Take a pause here to read the key if you need to. Each strand is labeled on the left to help follow along. The first mutation we will be talking about is a missense point mutation, which arises when there is one change to a base that results in the change of one amino acid. As you can see here, the third codon closest to the 3' end of the coding strand has an affected base. The cytosine base has changed to adenine. This is a change from a pyrimidine to a purine, which means it is a transversion. The change affects the mRNA coding for uracil instead of guanine, ultimately changing the amino acid in the protein. The second mutation is a nonsense point mutation, which arises when there is one change to a base that results in the premature stop codon. Here, the third codon closest to the 3' end of the coding strand has been affected. The cytosine base has changed to thymine. This is a change from one pyrimidine to another, which means this is a transition. The change affects the mRNA coding for adenine instead of guanine and turns it into a stop codon. The third mutation is the silent point mutation, which arises when there is a change to a base that results in a new codon that correlates to the same amino acid. Here, the fourth codon closest to the 3' end of the coding strand has an affected base. The adenine base has changed to guanine. This is a change from purine to another purine, which is a transition. The change affects the mRNA sequence, but not the translation of the amino acid. The final mutation is a read-through mutation, which arises when a base in a stop codon is changed, resulting in a new codon for the amino acid, as well as continuation of transcription. Here, the second stop codon from the 5' end is affected. The thymine has changed to adenine. This is a change from pyrimidine to purine, which means it's a transversion. The change affects the mRNA coding for uracil instead of adenine, changing the stop codon into the CIS codon. This concludes my submission for Mini Video Exam 5.